let's get into our lesson on radical expressions and rational exponents. Now today we are going to be identifying how rational exponents are related to radicals and roots. And remember, when we talk about rational numbers, we mean fractional numbers, right? So this time around, we're working with fractional exponents. So a rational exponent states for any natural number n, integer m, and real number a, when the nth root of a is real, the exponent m over n indicates the mth power of the nth root of a quantity, or the exponent m over n indicates the nth root of the nth power of a quantity. So there's two different ways we can work this out. First of all, let's look at the algebraic versions here. We have a to the power of m over n, which can be rewritten as the nth root of a, all of it raised to the power of m, okay? Or taking the nth root of a to the power of m. So these are the same expression, a to the power of m over n, but they are worked out in two different ways, okay? Now, looking at the number examples here, we have 27 to the power of 2/3. Taking the nth root of a, we have the cubed root of 27, which is 3, and then raising it to the exponent of 2 simplifies to 9. That's the first method. The second method takes the nth root of a to the power of m. So we have the square root of 4 to the power of 3, which is 64, and then the square root of 64 gives us 8. Now, these two methods, although they are different, they will provide us with the same answer, okay? So let's take a look at this 27 to the power of 2/3. If we were to have done it the other way, right, instead of taking the cubed root and then squaring it, we could also take the cubed root of 27 squared. Now, this is a big number. I don't expect you to know this off the top of your heads, but this does give us the cubed root of 729. And then taking the cubed root of 729, we still end up with 9. Okay? Same thing for 4 to the power of 3/2. I can take the square root of 4 and then cube it, right? The square root of 4 is 2, and 2 cubed still gives me 8. So it just depends on what type of problem you're working with, where you have to make the decision of what would be best or what would be easiest for you to work with, okay? Now, looking at example 2, it says express the radical expressions as an expression with a rational exponent and vice versa. So for these examples, we do have variables, okay? There's no difference. It works the same way. So given the fifth root of x squared, I'm going to take the root and move it down into the denominator, creating a rational exponent. So this becomes x to the power of 2 over 5. Okay, your root is the denominator in a rational exponent. Second example, we have t to the power of 3/2. I have a rational exponent. I'm going to rewrite it as a root. Okay, this time around, I'm going to take the exponent and I'm going to use it as the root. So we have the square root of t cubed. Okay, now remember, anytime we have a 2 or a square root, the 2 is not needed in the index, so it simply becomes the cubed or the square root of t cubed. Okay. All right, now let's do some examples here. We'll do a few of them together. We're going to translate the radical expression into expressionals with rational exponents and vice versa, and then we're going to simplify any numerical expression when possible. Okay, so we have to simplify as much as possible, and then assume all variables are positive. All right, so looking at example A here, we have negative 125 raised to the power of 4 over 3. Okay, that means we are taking the cubed root of negative 125. So we're going to do cubed root of negative 125. And then this is the part where you're going to determine, do I want to raise 125 to the power of 4? Or do I want to simplify this first and then raise that to the power of 4? I don't think we want to work with 125 raised to the power of 3, so we're going to simplify that first and then raise it to the exponent of 4. Okay? Cubed root of negative 125 is negative 5, and negative 5 raised to the power of 4 gives us 625, positive. So our answer here is 625. Example B. We have x to the power of 11/8. Again, take the denominator, convert it into the root, giving us the 8th root of x to the power of 11. Now, based on our examples up top, we know we can also rewrite this as the 8th root of x raised to the power of 11. So it doesn't matter which one you wrote down, right? What matters is that you have one of these. And again, it's all on preference. All right, for C, we have the 5th root of 6 to the power of 4/5. All we're going to do here, take the root, right, the index, make it the denominator, and we have 6 to the power of 4/5. Now, there's nothing we can simplify here, so we leave it as 6 to the power of 4/5. And finally, for D, we have the 4th root of x cubed, taking the index, making it my denominator, we have x to the power of 3/4. Okay, we do have a few more examples. Let's continue with those. Let's go ahead and do E and F, and then I'll have you guys try out G through L. So looking at E, we have 81/16, so this is already a fraction, raised to the power of another fraction, 3/4. So let's take this one step by step, okay? Remember, we are working with two different fractions. Keep in mind your properties and your order of operations. So the first thing I'm going to do is we're going to take the denominator and create a root with it. You do have your fraction in parentheses, so remember this applies to everything. So we're going to take the 4th root of 81/16, and I'm going to leave the power of 3 on the outside because we want to simplify these fractions first. Okay, remember when we're working with roots and fractions, we can split them up, right? We can take the 4th root of 81 and divide it by the 4th root of 16. This becomes 4th root of 81 is 3, and the 4th root of 16 is 2. Okay, now we still have to raise this to the power of 3. So we have 3 cubed to the power, or divided by 2 to the power of 3. Finish simplifying, and we have 27/8. If you are working this on your calculators, you can enter roots into your graphing calculators. So what you want to do is you're going to hit the math button. Let me write these out for you. You're going to hit math, and then you're going to scroll down to number 5. Number 5 shows you x as the index and a root. Okay, this is how you enter it into your calculator. Now, when you use this, when you use this in your calculator, you want to make sure that you type in the root first, then you hit math, then you hit number 5, and then you enter the rest of your problem. Okay, otherwise it will give you, it'll say answer in the root or in the index, and you want to make sure that you have that entered prior to you clicking the math button and then the number 5. Okay. All right, last one, let's take a look at F. Now, F says xy to the power of 5 cubed. When you have more than one value in parentheses, you have to remember that this applies to the entire thing, okay? So when we write it out, we know we're taking the cubed root of xy. Xy are both inside of the radical because they are both inside of the parentheses, meaning that the exponent applies to both of them, okay? When we raise it to the power of 5, we can, remember there's 2 different ways we can write this. We can write it with the power of 5 on the outside, or if you choose to write it on the inside, you must keep xy in parentheses to indicate that the 5 pertains to both of them, okay? If you were to write it out like this, xy to the power of 5, then you are telling me that the 5 only applies to the y and not the x. So if this is the method you are using, be very cautious when you're working with exponents. Make sure you're writing them correctly. Okay. All right. So I'm going to tell you guys, hit the pause button. Go ahead and try G through L, and then come back and check your work.